All right, so this is a lesson on how we can use the factored form of a quadratic relation to create an equation, or from the equation be able to create the graph. So we'll be able to use the x-intercepts, or they're also known as the zeros, and another word we're going to start learning is something called a root. So that's what we're going to work on today. So first off, this format looks quite different from the formats that we've used so far. We've used standard form, which tells us the direction of opening in the y-intercept. We've used the vertex form, which tells us the vertex, the direction of opening, and from there we can get a bunch of other information. So now we're looking at our final form. So this form up here is actually called factored form. So we have two different brackets. We can't immediately see that there's a squared here. However, we have two x's that are going to be multiplied by each other. So let's prove that it's actually a parabola. So when I fill in my table of values, so when x is -2, if I were to substitute -2 into those brackets, we're going to have -3 in the first bracket, 1 in the second bracket. So we are going to have +6. Then we will have -2 multiplied by 2 will give us -4. And then we are going to have 8. Okay. 0, we will have -1 times 3 is -3 times -2 is going to give us +6. I put in 1, we're going to have 0, because this middle bracket right here will have an overall value of 0, so everything will be 0. And I'm going to put in 2. So 2 take away 1 is 1. 2 plus 3 is 5. So we have 5. So I put in 2, take away 1. 2 plus 3 is 5. So we have -10. And then we have 3, take away 1 is 2. 2 times 6 is 12, times -2 is -24. So now we're going to do our first differences. So we have 2, -2, -6, -10, -24 plus 10 is going to be -14. So then we check our second differences. We get -4. -6 subtract -2 is -4. -10 subtract -6 is -4. And then once again we get -4. And then I'm quite happy that I see that it's negative, because I know our a value is -2. And remember, we looked at that little property that a will always be the second differences divided by 2. And if we check that here, we get -4 divided by 2, which equals -2. So that's a property that can help us down the road. And it is a parabola, guaranteed, because of the second differences being the same. And then if I were to actually plot the graph, scroll up a little bit so I can use my math feature here to generate the graph. It shouldn't come as a surprise that the graph is a parabola that's pointing downwards. Okay, and the placement of these values right here, the x-intercepts, that is not going to be a coincidence. So that's what we're really going to focus on today, being able to figure out those points. So to summarize, this is the factored form. So the a still means the same thing. It still tells us the width of the parabola, it tells us the direction of the parabola, but in this format, unlike the vertex form, we can't tell what the vertex is, but we can tell that the r and the s value, these here are going to be the x-intercepts. So with a parabola, we've seen parabolas where we have 2 x-intercepts, where we have 1 x-intercept, and also when we have no x-intercepts. And in that case, we can't have a factored form. Now, if we look at them, so if I were to mark on this example graph that I have right here, so I have a x-intercept at -5 and an x-intercept at +3. Where is the vertex in relation to those 2 points? It's in the middle. Your vertex is always in the middle of mirror image points, and our x-intercepts are there. So the question is, if I know the zeros, can I figure out the vertex? The answer is yes, we can. We can use the midpoint formula that we talked about, and as long as we have x, we can sub in to get y. So that's what we're going to sort of look at today. Okay, so we can definitely use that relationship to help us. Now let's have a look at this graph that I have right here. So right now I know that it's been vertically stretched by a factor of compressed because it's between 0 and 1. So it's a wider parabola. Now let's sort of look at these numbers that we have. Inside this bracket we have x minus 3. If I look at my graph, I have x equals 3 as one of the intercepts. I have x plus 5 up here, so that means this is x equals negative 5. What we're doing when we're finding those x-intercepts is we're trying to figure out what will make this 0. And actually I'm going to switch that and I'm going to do the plus 5 one. Okay, so I have plus 5 equals 0. So this becomes x equals negative 5. Here we have x minus 3 equals 0. So that becomes x equals 3. So that's where the factored form has something that we need to think about. So it's always going to be the opposite sign to what we have on the inside because we're finding a value to make it 0. Because we know that the x-intercept has a y value of 0. Okay, so here's the standard question that we have. Determine the x-intercept, zeros, axis of symmetry, and vertex of the quadratic relations below. Use the information to sketch a graph. Okay, so this equation right here, I'm actually going to rewrite it just for now. I normally won't do this, but I really want to emphasize something. Okay, so in this expression, there are two zeros. I have this value of x and I have this value of x. So I'm actually going to start by getting the 0 values. If I have x minus 0, that means this first 0 value right here is x equals 0. This value right here is x minus 4 equals 0. So x has to equal 4. So I figured out what my zeros are. The next thing I'm going to do is the axis of symmetry. So the axis of symmetry is the x value of your vertex. So I know that x is going to equal 0 plus 4 divided by 2. So we get 2. So that's the halfway point between our zeros. Now to get the actual vertex, I need to have y. So I'm going to substitute x into my equation. So I have 2 minus 4. So then I get 2 multiplied by negative 2 is negative 4. So the vertex of this parabola, so the vertex is going to be at 2 and negative 4. So I've done the vertex, I've done the axis of symmetry, I've done the zeros. So the last thing I need to do is the y-intercept. So for y-intercepts, we know that x equals 0. So if I'm starting from my original equation, I'm going to have y equals 0 multiplied by 0 minus 4, which is going to be 0. So that means the y-intercept is 0, 0. So with all of this information, we can come up with a pretty accurate graph. So that's what I'm going to do. I'm going to put in a grid. Okay. I'm going to have to move that grid down. Okay. I'm going to move the grid down. Move down all the way down to here. So in that question, we know that we had the 0 at 0, 0. We also had a 0 at 4, 0. And then we figured out that our intercept, or not our intercept, sorry, our vertex, I know x was equal to 2 and y is equal to negative 4. So I'm going to plot that point. So 2 and negative 4. Oh, my hand's a bit shaky today. So there we go. That's our parabola. It's a pretty shaky one, but that's how we get our sketch. So our next example, so I have y equals 3 multiplied by x plus 1x minus 1. So once again, we have two brackets. So we will have two zeros. So from this bracket right here, I'm going to have x plus 1 equals 0. So x equals negative 1. From here, I have x minus 1 equals 0. So x is going to equal positive 1. So I've stated my zeros. So now I'm going to do the axis of symmetry. So x equals negative 1 plus 1 over 2. So x is equal to 0. So from there, I want my y value of the vertex. So I have y equals 3, 0 plus 1, and then 0 minus 1. So that's going to be 3 times 1 is 3 times negative 1. We have negative 3. So that means the vertex is at 0, negative 3, which makes sense. And then the y-intercept, we are going to let x equal 0. So y equals 3, 0 plus 1, 0 minus 1. So our y-intercept ends up being the same as, as the vertex. So I have negative 3. So that's our y-intercept. So now that I have those things, I can graph it. So I'm actually going to do it on this same grid, just to. So I had a 0 at 1. I had a 0 at negative 1. And then 0, negative 3 was our y-intercept. Okay, again, it's a bit wobbly because of the slate that I'm using. Now this makes sense because of the 3 that we had out in front. It should be a skinnier parabola because it's been vertically stretched. All right, so our last example, I'm actually going to grab the equation and move it down here. So looking at this here, I see I got some different transformations going on. I got a reflection, I got a compression. That doesn't really change how we're going to look at the zeros. So starting off with the zeros, so I have 2 zeros. So I have x equals negative 6, and I have x equals 2. Then I'm going to do my axis of symmetry. So I'm going to have x equals negative 6 plus 2 over 2. So x equals negative 4 to negative 2. That's my axis of symmetry. Then I'm going to get y. So I have negative 1/2, 2 plus 6 times 2 minus 2. And it should be a negative. So y is going to equal negative 1/2. So negative 2 plus 6 is 4. Negative 2 minus 2 is negative 4. So y is going to equal negative half of negative 16 is going to be positive 8. Oh, that doesn't look like an 8. It's going to be an 8. So that means the vertex is at negative 2 and 8. And our last thing we need to find is our y-intercept. So we will have y equals negative half. 0 plus 6 is just 6. 0 minus 2 is negative 2. So we have negative half of negative 12 is going to be positive 6. So let's graph that one. So when I graph this one here, I have a 0 at negative 6. A 0 at positive 2. So this makes sense that they're really spread out because we know there's a compression. And then my vertex is at negative 2 and 8. Oh, I'm a little bit off this graph, so I'm just going to estimate it to be right here. So then I'm going to look at my y-intercept, which is at 0, 6. Now, I can actually use this to help me a little bit to sketch. So when I'm at the vertex, I went from 8 to 6 and then over 2. I have that same symmetrical point on the other side. So that's just going to help me curve my parabola. All right, and again, if this was on paper, I'd expect them to be a little bit smoother, but it's hard with the pen and the slate. So from factored form, we can glean all this information. Okay, so now the flip side. So determine the equation of the following quadratic in factored form. So it has zeros at 2 and 3. So that means x equals 2, and this means x equals 3. Up here, it's saying in factored form. So just like we would start with vertex form, factored form looks like this. Okay, so I have y equals a. X, if x equals 2, it's going to become x minus 2. And if x is equal to 3, it's going to be x minus 3, because we're bringing the x over to the same side. Now when we have vertex form, once we put the vertex in, we needed another point. So that's where the y-intercept comes into play. So the y-intercept is actually the point 0, 6. So I'm going to substitute that in and solve for a. So I have 6 equals a, 0 minus 2, 0 minus 3. So that becomes 6 equals negative 2 times negative 3 is going to be 6a. Divide both sides by 6. So 1 is equal to a. So that means our equation is going to be y equals x minus 2 and x minus 3. So there's one example. So we're going to do the same exact thing in the next example, just using different numbers. So I'm going to start with y equals a. So this is negative 4. So in here it's going to be x plus 4. And then we have x minus 5. That's a 5, not a 3. So from there, I need to figure out what a is. So that's where the point comes into play. So I have 36 equals a. 2 plus 4 times 2 minus 5. I'm going to have 36 equals a. 6. Here I have negative 3. I'm just going to move over here. So 36 equals negative 18a. Divide by negative 18. Divide by negative 18. Negative 2 equals a. So that means our equation is y equals negative 2 x plus 4 and x minus 5. All right, so the last type of question you're going to get here, where there's no like context, is you're given the graph. So when you're given the graph, you want to start off by identifying some key values. So right here, I see that this point is at 3, 0, and this point is at negative 5, 0. Okay, it's a 0. So I have the 2 points, so I'm going to go ahead and put those in. So I'm going to have y equals a, x plus 5, because we're always using the opposite, and x minus 3. Then I need to find another point on the graph. So we want to find an accurate point when we're looking here. And in this case, our vertex is actually an accurate point that I can use. So we have negative 1 and negative 8. So I'm going to sub that in. So negative 8 equals a, negative 1 plus 5, negative 1 minus 3. So I have negative 8 equals a. I have 4 and negative 4. So negative 8 equals a times negative 16. Divide by negative 16, divide by negative 16. So I get 1 over 2 is equal to a. And that makes sense. It should be positive because it's opening upwards. And it does look compressed. So our final equation for that graph is going to be y equals 1/2 x plus 5 times x minus 3. All right, so that's the end of our lesson on factored form. If you have any questions, please come see me.